And so, as I mentioned, adding radicals, we can add radicals if they have the same, what's called the radicand, which is the number inside. Same number inside, and the same index. Okay, when we add them, we simply add the number in front of the radicals. You need to just think about these as like terms, right? When we add 2x plus 5x, don't we just say the answer is 7x? We don't change what the x is. We don't change the variable. So when we have 3 square root of 2 plus 2 square root of 5, we can't add these because these two numbers are different. And these ones, this is the cube root of 10 or the third root of 10 plus the square root of 10. We can't add these either because these are different roots. I'm going to say different index. The index is the number right there. It tells you what root it is, or a different root. But here you see we have 5 square root 3 plus 2 square root 3. All we do here is 7 square root 3. They're the same number inside the root, so we can just add them like as if they were like terms. Same thing here. These both have a 5y inside. Have the 8 there, a 2 there, so this just becomes 10 with the root 5y, just like terms. Now here we have several terms here. I'm seeing a root 3 here, 5 root 3, and minus 2 root 3. Those look like they can be combined. Just like sometimes we have different variables, we can only combine like terms. We can only combine like roots. 5 minus 2 is 3. Let me attach the root 3. And these ones here, these both have a root 2. Okay, we have negative 2 minus 4. That makes minus 6 root 2. Same thing here. This one has a root 3 and a root 3. 4 minus 2 is 2 root 3. And these both have a root 3x. Now this is 5. What number is in front here? Isn't it a 1? So that's a plus 6 root 3x. Now you might think that we can't add these together because the numbers inside are different, but it's actually hiding that they can be added together. Let's actually break each one of these up. Root 12, I can break this into 4 and 3. And 4 is 2, right? I break it up into 4 and 3, and I choose 4 because the square root of 4 is 2. I don't choose 6 and 2 because I don't know the square root of 6 and I don't know the square root of 2. What about 75? When I think of 75, I think of quarters. I think of 25 times 3. So this is 5 root 3. So what this actually turns into is 2 root 3 plus 5 root 3, right? We've switched this to this, and the square root of 75 to 5 root 3. You see how these have the same number in the root now? 5 plus 2 is 7. Now this one here, 10 root 3, has a root 3 attached. I'm wondering maybe if this can simplify somehow and have a root 3 attached to it. Well, let's see, 27. This can break into 9 and 3. Square root of 9 is 3. So this entire thing, let me drop this down. Well, I suppose I could just do this. Right, this changed to 3 root 3. I'm just dropping this down. 10 root 3 minus 3 root 3 is 7 root 3. Hey, it's the same answer. That's funny. A couple more here. Of course, again, different number in the root. But let me see. I'm going to take this one over to the side. Square root of 45, that is a little bit big. What can I break it into? How about 9 and 5? Square root of 9 is 3. 4 times 3 is 12. 3 root 20. 20 is a little big. And so I can change this into 4 and 5. Because I know the square root of 4 is 2. 3 times 2 is 6 root 5. So I have changed this to this, so I'm going to drop that down here. And look, now they both have the same square root 5. 12 minus 6 is 6. Final one here, again, these, of course, they don't have the same thing in the root. Let's see. But let's take each one of these individually. I'm going to give the 6 its own root and the x squared its own square root. 6 doesn't break into anything except 2 and 3. So I don't think we're going to have any luck there. But the square root of x squared we know is just x. And as I've been saying, I like to write this at the end of the term. So I'm just going to rearrange these. Don't forget that this is a minus here. X root 24, let's see. 24, I know I can break it into square root of 4 and the square root of 6. 4 times 6 is 24. I know the square root of 4. It's 2. And of course, I really like to see this as 2x root 6. I don't like to see a variable in front of a number. I like to see the number in front of the variable. So I'm just moving these around because these are all multiplied. I can do that. And so 4x root 6 minus 2x root 6. Notice that they both have x root 6. That's really important. So all I'm going to do is work with the numbers in front. 4 minus 2 is 2, and then I'll attach this